Deceptive Realism. Quantum Lies Part 3. Local Realism. It is often stated that John Bell and his Bell's theorem had disproved local realism. In philosophical terms, realism is typically associated with belief in the existence of an objective reality independent of the observer. If we want to preserve locality, some physicists interpret this as meaning that quantum mechanics has disproved the existence of objective reality. Quote, "Most working scientists hold fast to the concept of realism, a viewpoint according to which an external reality exists independent of observation. But quantum physics has shattered some of our cornerstone beliefs." End quote. Quote, "The scientific method relies on facts, established through repeated measurements and agreed upon universally, independently of who observed them. If one holds fast to the assumptions of locality and free choice, this result implies that quantum theory should be interpreted in an observer-dependent way." End quote. This claim is used by various idealist philosophers and physicists alike to conclude that the physical sciences have disproved the existence of physical reality. Bell, Einstein realism. Term realism in physics is often conflated with the philosophical definition. The philosophical definition of realism is, again, belief in an objective reality independent of the observer. The physical definition originates from the Einstein-Podolsky-Rosen paper, in which Einstein puts forward a criterion for reality, stating that a physical theory that is descriptive of reality should track all observables. Quote, "Every element of the physical reality must have a counterpart in the physical theory." End quote. Bell's theorem addresses this criterion for reality, arguing that a theory which can track all observables could not also be local. Locality, as Bell uses it, refers to Lorentz invariance, meaning compatibility with special relativity. Quote, "In a theory in which parameters are added to quantum mechanics to determine the results of individual measurements, without changing the statistical predictions, there must be a mechanism whereby the setting of one measuring device can influence the reading of another instrument, however remote. Moreover, the signal involved must propagate instantaneously, so that such a theory could not be Lorentz invariant." End quote. Abuse of terminology. Many physicists abuse the term realism used by Einstein and Bell by conflating it with the philosophical definition, stating that Bell disproved the existence of a reality independent of the observer. Bell was operating on a completely different understanding of realism, which was built off of the EPR paper he was responding to. Realism in the philosophical sense is perfectly compatible with quantum mechanics. A realist interpretation of quantum mechanics tends to take on two different forms: metaphysical realism, with hidden variables, and contextual realism, without hidden variables. Metaphysical realism. There is a separate myth that John Bell disproved hidden variable theories. Bell only proved that if a hidden variable theory exists, it must be non-local, or superdeterministic, but I will put that aside for now, for simplicity's sake. Bell himself was an advocate for non-local hidden variable theories, specifically promoting Bohm's pilot wave theory and criticizing those who did not take it seriously. Quote, "Why is the pilot wave picture ignored in textbooks? Should it not be taught, not as the only way, but as an antidote to the prevailing complacency? To show that vagueness, subjectivity, and indeterminism are not forced on us by experimental facts, but by deliberate theoretical choice?" End quote. Given that non-locality is defined as a violation of Lorentz invariance, this would make such theories not compatible with special relativity. Quantum field theory is a unification of quantum mechanics and special relativity, and thus makes better predictions than quantum mechanics alone. This, in turn, makes non-local interpretations, such as Bohm's pilot wave theory, possess less predictive power. There is no proof this issue could not be resolved with a reformulation of special relativity, which is something certain researchers like to model and looks into. However, there is no agreed upon solution, so such interpretations remain unpopular. Contextual realism. Rather than trying to modify quantum mechanics with hidden variables, contextual realism allows for a realist interpretation of quantum mechanics which interprets quantum mechanics as is, without modification. Such a point of view would accept that all observables cannot be tracked, but that this is not a problem for philosophical realism. Since this interpretation avoids positing that all observables can be tracked despite being philosophically realist, it is not realist in the EPR sense, thus allowing for it to also be a local interpretation, that is to say, to be Lorentz invariant. Wave functions are reinterpreted as not descriptive of physical entities, but a normative tool used to make predictions about what will be observed in the context of a specific measurement. They thus describe the dispositional character of particles to interact in particular ways under particular contexts, rather than representing some metaphysical object. You cannot extrapolate, using wave functions, the unique histories for all the particles, but that does not take away from the fact that it is indeed making predictions about the behavior of real things which are really identified in context. Quote, "Our interpretation allows us to explain the EP or paradox without invoking the hypothesis of non-locality of quantum mechanics. The cause in a generalized sense of quantum correlations is the entangled wave function. The correlated quantum events are not autonomous, but they are determined in the context of their observation. Independently from the means of their identification, there are no events." End quote. There is also a close relationship between this and relational quantum mechanics. Observer effect. It is often claimed that in quantum mechanics, the act of conscious observation collapses the wave function and alters the system. In a metaphysical realist interpretation, there is no wave function collapse because the outcome is predetermined by some hidden variable. Probabilistic spread, which the square of the wave function describes, only exists because of the observer's ignorance of the value of the hidden variable. That does not mean all metaphysical realist interpretations are entirely epistemic, as some do also posit the existence of some sort of metaphysical wave that plays a role. In a contextual realist interpretation, the wave function is not a metaphysical entity, so it is not something that can be collapsed. It is just a normative tool that describes the dispositional character of particles to manifest themselves under particular circumstances. The act of observation, furthermore, does not actually influence the system. Rather, by taking action and interacting with the system, the observer changes the context in which they are situated in relation to the system, and thus changes the outcome they observe. As an example, consider Galilean relativity. Velocity changes depending on frame of reference, but this does not mean changing your frame of reference is changing the object being observed. Quote, "Speed, for example, is a property that an object has relative to another object. If you walk along the deck of a ferry, you have a speed relative to the ferry, a different speed relative to the water in the river, a different one relative to the earth, another relative to the sun, another again relative to the galaxy, and so on, endlessly. Speed does not exist without being anchored implicitly or explicitly to something else." End quote. Carlo Rovelli, Helgoland, Making Sense of the Quantum Revolution. Conclusion. Bell's theorem does not in any way, shape or form disprove the existence of objective reality independent of the observer. It only shows an incompatibility between Lorentz invariance and the ability to track all observables. Realism in the philosophical sense can be maintained either by, first, violating Lorentz invariance. This requires mathematically modifying quantum mechanics in order to replace its current formalism with one that contains hidden variables that can be used to track the observables. Or, second, by abandoning the belief that all observables can be tracked and assigned unique histories. This requires a philosophical, not mathematical, alteration to the understanding of the relationship between physical theories and reality, typically adopting some sort of anti-metaphysical understanding of reality. There is no scientific reason to deny the philosophical concept of realism, that is to say, belief in an observer, independent, objective reality. If you want to deny it, it would be a philosophical position, not something which is justifiable by the science itself.